In this lesson, we are going to learn how atoms become stable by looking at the periodic table and specifically the Lewis dot structure on the periodic table. We will only focus on the main group. Okay, the pattern applied to the main group, which are group A. So here I have group 1A all the way group to group 8A. Here I have a general Lewis dot structure for all the main groups. Now what does it mean to be stable? All atoms want to be stable, but only one main group on the periodic table is stable, and that is group 8A. So in order to be stable, you need to have the Lewis dot structure that look like group 8A, which is this one right here. It has 8 valence electrons. Okay, so 8 valence electrons. Or you can have 2 valence electrons where the 2 electrons are shared in that specific orbital. These are the 2 possible Lewis dot structures that indicate an atom is stable. So how do atoms become stable? Before we can address how atoms become stable, we need to realize that the Lewis dot structure only shows the valence electron. And valence is outermost electron. So we look at this compound right here. Here we have sodium. This is a Bohr model of sodium. Notice all those little dots are electron, but the outermost electron is this one right here. And sodium is in group 1A. That's why I put it right here. So look at sodium. That would be Na like this. This would be the Lewis dot structure for sodium. So again, all the elements in group 1A will have the same Lewis dot structure, even though their number of electrons are not the same. But because they have the same number of valence electron or the same Lewis dot structure, their properties, their chemical properties is very similar. Let's go back and look at some of the ways that atom becomes stable. One way an atom becomes stable is by either losing or gaining electron when reacting with other atoms. Before we can apply this, we have to realize that electrons, they are negative. Okay, negative charges. What does that mean? When you lose electron, you lose the negative. What is your charge gonna be? Because in the end, the positive charge in the proton is canceling out with the negative charge of electron. So if you lose your electron, your positive charge is still there, so you become more positive. In this case, when you lose electrons, you are becoming a positive ions. Where when you gain electron, you are gaining the negative. Remember, electrons are negative. It will become a negative ions. But what are ions? Ions are basically atoms with charges, with positive or negative charges. Okay, that is the basic definition of ions. So by gaining or losing electron, it becomes stable and it becomes an ion. So how does that work? So let's look at this Lewis dot structure. Again, X is a generic symbol represent any elements in group 1A. It has one dot. It has two options. One option is to going forward this way and gain how many more? It has 1 already, so it has to gain 7 more electron. So you can gain 7 electron. Or the other option, if you realize, you look at the periodic table, there's just one row on the periodic table. It can lose this 1 electron. See how it loses 1 electron? So the inner electron is going to be exposed. So this one now becomes the outermost electron, which is 8. So it come back here, it look like this. So it's going to lose this electron and it's going to have nothing. But that nothing right there is going to be like this. Why is that? Because the inner electron are now exposed and it becomes the valence electron because that outer shell is no longer there. So The other option is to lose one electron. With these two options, you have to compare in terms of values which one is smaller. The smaller it is, the easier it is to become stable. In this case, gain 7 electron or lose 1, so of course, losing 1 would be the easier option. That's why all the elements in group 1A will lose 1 electron and they become an ion that has 1 positive charge. An example would be sodium in this case that we're looking at. Therefore, you will see sodium to have 1 plus charge all the time. Let's look at group 2A. It has 2 electrons. The one option is to gain 6 more electrons. The other option is to lose 2 electrons and come back all the way over here to have this kind of Lewis dot structure, but it actually really look like this. Okay, so which one is smaller? Of course, losing 2 electrons. That's why all the elements in group 2A will have a generic ion symbol like this, 2 plus. An example would be calcium 2 plus. There you go. And when you write the charges, make sure this is a superscript. Let's look at group 3A. It has an option of gain 5 electrons or an option of lose all 3 electrons. Of course, losing 3 is a lot easier, so you would have X3 plus. One example would be aluminum 3 plus for group 3A. And then we go to 4A. 4 is like right in the middle where you can have gain 4 electron or lose 4 electron. Well, 4 and 4 is the same values. Guess what's gonna happen? This whole entire group electron, or all the elements in group 4A are mostly sharing electron. That is the next type of chemical bond that we're gonna work with. So they are sharing electron, so all the elements in group 4A are more likely to share electrons. Because the option of gaining 4 electrons is equivalent to the option of losing 4 electrons. So for 4A, they all wanna kind of share their electron. Then we get to 5A, you have the option of gain 3 more electron or lose all 5 electron. In this case, gaining 3 is a lot easier because smaller. So therefore, guess what happened? When you gain electron, remember electrons are negative, so we become more negative. In this case, you have this type of ion, 3 minus, because you're gaining 3 electrons, okay? One example would be nitrogen 3 minus. Let's move on to 6A. You can have an option of gain 2 more electrons. 6 plus 2 gives you 8. So again, the goal is to get 8 valence electron or to be like helium somehow. Or the other option is to lose all 6 valence electron to expose the inner ring. Which one is easier? Is gaining 2. Since it's gaining 2, it would gain 2 negative. So therefore, the charge would be negative 2. Again, electrons are negative. That's why gaining is negative. One example from group 6A would be oxygen 2 minus. And if you notice, all the elements in group 6A will have 2 minus. And then we have 7A. One option is to gain 1 more electron or to lose all 7 electron. Of course, the obvious answer would be gain 1 electron. That's why all the elements in group 7A would have this type of charges, 1 minus. One example would be fluorine 1 minus. And lastly, we have group 8A. It's already stable. It's not going to do anything. That's the reason why, have you noticed? Helium is very stable and it's very safe. Think of the helium balloon that you have during your birthday party. Because if helium is not stable, that wouldn't be a fun birthday party to go to. So let's look at the whole entire thing together. We notice that the main group has specific pattern about their charges based on their choice of becoming stable. But one thing where you also want to look at is how easily do they want to become stable. For instance, group 1A, they only need to lose 1 electron. So they're extremely unstable. This is one of the most unstable group on the periodic table, because all you have to do is just lose one electron. So all the elements in group 1A are extremely unstable. That means they will react with almost anything. For that reason, most of the elements on this 1A will be combined with other compound. They exist in a compound. The same thing in group 7A right here, okay? It's just to gain one electron. So this is also another most unstable. So group 7A and 1A are very unstable. And that is how you determine if an atom is going to become a positive charge, a negative charge, or share electron. And these are all examples of all the ions for each of the main group. The activity that go along with this video is, first, draw the loose dot structure for each element, okay? Second, you're gonna state how it becomes stable if it becomes an ion, right? The ions. For instance, let's talk about lithium first. So lithium is right here, so it's gonna be right here. So this is Li with one dot. Because it has a Lewis dot structure, one electron is gonna lose one electron. So that's how it becomes stable. Lose one electron. If we lose one electron, what is the ions going to be? It's going to be Li 1 plus. Right below lithium is sodium, which is Na, and has the same Lewis dot structure. Therefore, it's going to lose one electron, and it's going to have Na 1 plus. Now, be careful only doing the A group only, okay? However, there is one exception to this rule, and that is hydrogen. That's why I didn't show you first. Hydrogen is very special because it has one valence electron. However, hydrogen can become stable in two different ways. One way is hydrogen is gonna gain one electron and has an H2, okay? So it's gaining one electron, it would become like this, like helium. But it also can become stable by losing one electron, and it becomes like this, no electron at all. So if it's gaining one electron, it would have an ions of 1 minus. If it's losing one electron, of course it's going to have an ions of 1 positive. So for hydrogen, it would be gain one electron to become 1 minus, or to lose one electron to become 1 plus. So again, hydrogen is an exception that you need to remember.